Hello, my name is Dr. James Case, and I am the Chief Scientific Officer at Cardiovascular Imaging Technologies. This educational video will demonstrate how to identify the correct blood pool region of interest for absolute quantitation using the ImagenQ version 2.0.2 software. Correct identification of the blood pool region of interest is the most important step in making reliable and accurate measurements using ImagenQ. To make the measurement of the blood pool ROI, the study is first brought up within the ImagenQ processing window. First, we click on the Reposition Roi button. This opens up a dialog displaying a short axis, horizontal long axis, and vertical long axis view of the myocardium. We can scroll through the dynamic frames using the top toolbar. In the top toolbar, we identify a good blood pool image. The good blood pool image can be identified by the septal wall separating the left ventricular cavity and the right ventricular cavity blood pools. To then identify where to place the blood pool ROI, we recommend using an ROI centered within the left atrium. By identifying the left atrium, which is directly behind the left ventricle in the central image, we can then see how it is displayed in the other two views. So we click on this and then identify within the short axis the central circular blood pool at the left atrium with our region of interest centered in it. And then we can look in the vertical long axis view, the same view of the region of interest within the left atrium directly behind the left ventricle. By using these three views, we can accurately identify the correct location for our blood pool ROI. Again, click on the Reposition ROI. Step 2, identify using the top scroll bar a good blood pool image. This is usually seen as a separation between the right and left ventricle, as we can see here. And not all views of the blood pool are as clear as the first one. Some may be more like this, where it's a little harder to see the separation between the right and left ventricular cavities. Then we use the bottom scroll bar to find the optimal slice. And then we select the blood pool ROI that we want to use. Fine adjustments can be made using the incremental steps at the bottom. In the X direction, in the Y direction, and finally in the Z direction. Once we have what we believe to be a good blood pool ROI, we can conduct some specific quality control steps, the most important of which is the peak to plateau measurement. This peak to plateau measurement is a measurement of the activity at the peak of the blood pool curve divided by the plateau value out at 150 seconds. For these views, we expect to see the peak activity being at least 6 or greater. In this case, if we're with the regions that we've chosen here, these well exceed the factor of 6 that we would expect. Any factor less than 3 should be considered problematic. For instance, if we had selected an inaccurate blood pool ROI, say over here, this would reduce the peak to plateau ratio and soften the peak, helping us identify that we've missed the central blood pool ROI. Again, repositioning it where we would like it. Once we believe we have a good blood pool ROI, we can then display our final blood flow results. And in this case, we have a normal study with normal stress flow, normal resting flow, and normal reserve. To request more information or to schedule a training session on how to use the ImagenQ software, please contact Stacy Corder at scorder@cvit.com. The telephone is listed there. And also to learn more about this or other products and services offered by Cardiovascular Imaging Technologies, please visit our website. Thank you for watching, and please subscribe to CVIT for more educational videos related to cardiac PET and cardiac SPECT.